Hey everyone, I'm Jeanette Barnard, creator of Prime Future, and today I have with me Jesse Hoff. Jesse, thanks for joining us today.
Real pleasure to be here.
Excellent. Well, Jesse, I enjoy your Twitter commentary on all things from the science of COVID to a broad range of topics across the meat industry to ag tech. So hopefully we'll get into some of that today, but let's just start with give us a 60-second version of your background.
Sure. So I am a PhD in animal genetics and genomics, which I did at the University of Missouri, where we focused on the use of genetic data to improve the breeding and selection management of livestock with a particular focus on cattle. My work generally has been to uh, uh, use genetic tools and take advantage of this really exciting opportunity and window that we're in the livestock genetics industry to use genetic tools to improve the way we make those decisions. And there's a lot of different organizations around the world that are using that kind of data. And currently I work at an awesome company where we are trying to transition the basis of the technology that's used for generating genetic data to improve cattle and other livestock species from the current technology that has become extremely popular and prevalent to one based on a new molecular method for generating that data called sequencing. So there's really a rich environment and infrastructure around genetic data in the livestock industry. And my goal and what I think will continue to play out for the next 15, 20, 30 years of what's been a very interesting career thus far is how can we improve the genetic data that we're generating? How can we create new opportunities to use that data? How can we come up with new business models based on that data? And how can we continue to expand the application of where we are using genetic data in livestock today?
Oh, okay. So you use a lot of words that I really like there. So talk to us a little bit about as you think about genetic sequencing data. I think you maybe just mentioned a list of what some of the potential benefits are, but what does that allow us to do that we can't do with current forms of genetic data?
Sure. Well, I think probably best to start with kind of our square one of where we're coming from and how we're using genotype data in the livestock industry today. So really the success that the livestock industry has had in adopting genetic data has been based on the fact that there was a really sophisticated system for making breeding decisions already in the livestock industry. And we won't go on too much of a history lesson today, but the fundamental basis of that is establishing a pedigree and understanding the fundamental question of which bull or which cow or which chicken is best to make improvement in my population going forward. Mm-hmm. And that analysis was based on an understanding of how genetics worked before we actually had any information about what was going on in those individual animals' DNA. Once we started to be able to measure that, actually, really the most powerful thing and something that always plays a really interesting role in all the different industries where genetic data is important is being able to just understand, what the identity of an individual is, what the identity of its parent is. So starting from the 70s or 80s, we had a lot of parentage testing, which really improved how well we could make these evaluations because there was a lot of error in it. And then as we've gone along, we've been able to, in different industries, in cattle sector and in the swine sector and in the chicken sector, get more of an understanding of the impact of individual genes, where we might understand resistance to a disease or something that has a large effect on back fat composition, or something that impacts the presence of a specific protein in a milk profile or something like that. And as the molecular technology for analyzing that has progressed, we've continued to have a framework for just making statistical evaluations of the quality of an individual in the context of an overall breeding program. And about 15 years ago, data sets started to exist that would allow you to get a pretty comprehensive understanding of the entire genome of an individual at tens of thousands of data points for less than $100. These were kinds of technologies that were coming out of efforts in broader molecular genetics and the Human Genome Project. And around 2006 or 7, we had a cow genome available. And the technology being used there, the microarrays, was starting to get to a point where we could actually do a better job of understanding, once an individual was on the ground, what their performance was going to be at a comprehensive level across a variety of traits, looking at the exact same information essentially that we would be in a traditional pedigree evaluation, but directly observing what was driving that performance. And previously, what you would have to do is you would take a bull, and all of their half siblings, you'd mate them to a variety of individuals, and you'd figure out which one of their offspring did the best. And that process really, in comparing a bunch of different half siblings, is something that you can get a very powerful understanding of without knowing all the specific genes that contribute to it. But as long as you can compare the relative relationships amongst those half sibling individuals, you can do a lot to predict which one of those will be the best sire of future offspring. And so we had a drop-in model ready to go, where in other fields, has been a lot of effort to try and really understand all the thousands of individual genes that contribute to performance. And that's a difficult path, but in livestock breeding, there was a really direct approach to be taken, and it's led to massive adoption of this kind of technology, which we broadly refer to as genomic selection. And to that end, millions of animals have been genotyped over the course of the last 10 years with this microarray technology. And really, the first great thing about the sequencing technology that we use is that it allows you to generate the same kind of data and do what we've been doing already with much more flexibility in setting it up for any kind of species or population, as well as begin to build a much richer data set for making an analysis of that individual that can be customized more, that can lead to more biological insight at essentially the same price point as the existing technology.
Okay, so there's obviously just a really complex space. There's a lot that you just described there. You talked about rapid adoption or widespread adoption. Give us a sense of, if you look at the US beef industry, what percentage of the beef industry is embracing this kind of technology?
Yeah, it's a great question. And to me, this is all about perspective, because I started my PhD around 2012, and the US beef industry was 3 or 4 years behind the dairy industry at that time in the adoption of this particular technology. I remember a lot of folks in the industry looking at it and saying, boy, this is something that the beef industry is going to continue to be slow to adopt, because the beef industry has a reputation for being slow to adopt a variety of technologies. I guess I had an optimistic attitude about it at the time, and I would say that returns have been pretty good. There are hundreds of thousands of beef genotypes generated every year. A pretty substantial proportion of the registered animals in the industry are genotyped, and that leads then to, at the seed stock sector, for example, I think a growing level of understanding that if you're going to have a bull sale and you're going to have EBVs or breeding values associated with that and predictions of performance, those better be based on genotypes, because those are vastly more informative for a yearling bull if they have a genotype attached to them than if they don't, right? So that's kind of the starting point of where we're at, and that took 4 or 5 years to get to, and I happen to think that's a pretty quick turnaround time. By comparison, in the dairy industry, they made a comprehensive transition over to essentially no bull semen was being used if it wasn't genotyped, basically 100%, right? And on the AI side in the beef industry, there's no AI semen essentially that isn't genotyped at this point, period, right? But in the dairy industry, of course, AI makes up a much larger proportion of what they're doing. And now they've gotten to, so the North American evaluation run by a group called the CDCB does close to about 1 million genotypes a year, collected, directly paid for by farmers and used to analyze the overall performance of all the individuals in the herd, in the Holstein breed and others. And with that, that's basically, somewhere around 10% of the entire US dairy industry being genotyped every year. That's now reaching a level where they're really actively driving decisions about the management and inclusion of females in the milk production group. And has also led to additional management decisions that folks might be aware of, like the use of beef on dairy, which is a massive trend and an important one to understand. And really something that's enabled that is the ability to say, okay, I have 500 female milking cows. I need to generate a certain amount of replacement animals out of them. I know which ones are good and which ones are bad. Previously, you couldn't identify which ones are good and which ones are bad very well, because you only get one cow per year out of a dairy animal, and so you don't have that much information about them. So first you add in a genotype layer, and you can say these are the good females and then these are the bad females. Now we have another technology that makes that even more powerful, because there's been widespread adoption of sex-biased semen, right? And so with that, you can achieve your breeding goals in a limited amount of conceptions and pregnancies in the elite part of even a mid-sized dairy's herd, and still achieve the genetic progress to build a strong foundation and improvement of the herd, and then have beef semen, being used in the rest of the individuals. And that creates a pretty major delta on the profitability of that cull animal coming out the other side. So yeah.
Yeah. Okay. So there's a lot here too. From conversations I've had in 2020, I think this beef on dairy capability and the opportunity to increase the value of those cull animals, that seems like one of the potentially most disruptive dynamics for the entire beef industry. Because thinking about just the number of head within the dairy industry, that if you started to see widespread adoption of that approach, that could really impact the economics around the beef side. One of the things that I've consistently heard, and I want to get your feedback on this, but one of the things I've consistently heard is that a challenge here is, again, the fragmented beef supply chain. So the dairy producer, where are they going to sell that animal to, if it is a beef animal? And then from the genetics company perspective is, how do you, that animal the beef animal that's going to perform better in a feed yard and ultimately in a plant, how do you get the right players aligned to incentivize the dairy producer to use that beef on dairy approach? What's your response on that, and the importance of that new business model you mentioned early?
Sure. Well, and I think it's a great couple of questions, and really kind of gets at the overall set of opportunities that we see out there in the industry right now. And even if there's kind of a slow moving wave to see something like this develop, where sex semen technology existed 6 or 7 years ago, or 10 years ago. I couldn't put an exact date on it for you. And there were tools available to the dairy industry with fairly widespread adoption of genotyping on the commercial female level that were affordable around that time. And now, it's something that's grown pretty substantially it could have grown faster, but I'd say it's grown pretty fast. And then it raises these whole other series of follow-on questions. I think that, to your first question about how do you build kind of that chicken and egg supply program around that, I think there's a lot of opportunity for the dairy industry, which can do a good job about really going after a goal and achieving it, to create and set up the infrastructure for a very high quality beef supply chain that works kind of within the capabilities of what they've got. It might not be everything that a crossbred high performance Angus Hereford steer is out in the Mountain West. But I'm from upstate New York originally. They don't necessarily have all of the same infrastructure and resources there, but this is exactly that kind of disruptive opportunity, because there is a major opportunity to take advantage of those kinds of animals now, and there's a lot of agility to dial in the genetics of that to meet the need of whatever the optimal use of that supply may end up being. So if they need to, figure out how to change the profile of the female, to change the carcass composition a little bit, to change the fleshing ability of that animal a little bit, or to identify the right beef sires and breed combinations that lead to the optimal performance there. There's a lot of ability to do that. And the incredible thing that excites me the most about what we're going to see in the next 10 years is that we have several million genotyped females in these dairy herds, and there's a tremendous amount of opportunity to take the data of their performance in the milking system, but then of course beyond that, to then look and see, okay, this genetic information that we have on the mother, potentially the genetic information that we have on the beef on dairy calf, and their subsequent performance, put that all together and really get a very high level understanding of what the product performance is, from the feedlot to the slaughter facility to the consumer's plate and in the retail environment, et cetera. And it's a very powerful framework and tool, and there's a lot of different ways that data can be used, and I think we will continue to find more interesting ways to drive that conversation forward. So
that's awesome. So two more quick questions for you. So the first one is, you talked about kind of beef versus dairy in terms of sophistication of how they approach this genetic space. How would you compare beef and dairy with swine and poultry? Who's the most sophisticated from a genetics framework perspective? Which species?
We're in a really fun opportunity here, because there's different and interesting ways that this data, that the data that Gencove produces, can be used in all these different sectors. And I've been really impressed and personally excited about the opportunity to get some insight with the different projects that we work on into how these different industries are approaching it. And I do want to, be clear that I don't think there's necessarily one clear industry that leads over all others in sort of terms of their sophistication, okay, or the different types of opportunities that there are. There certainly is a history of bad mouthing of the beef industry, and I come from a beef operation myself, so I won't necessarily stand for it. But in comparison of the poultry industry and the swine industry, as folks may know, the structure of those organizations that provide genetics and germplasm in those two areas is highly consolidated, and they've been able to make quite a lot of use of this kind of data. It accelerates the performance of their programs. I think it's quite fair to say that it has led to further consolidation of those industries. Groups that have not been able to adopt this genotyping technology will be left behind in their performance. But I think it also creates, countervailing opportunities for specialization to meet specific segments and address specific challenges with a smaller footprint, with less of a massive resource for breeding sows and hens and roosters. And I think that the final impact of that story is going to continue to evolve. So those are industries where they already have quite a bit of sophistication in the programs that lead things. But we saw recently just now the launch of a new swine genetics program in the U.S. by Mashoff's group, a company called Agrigenomics. And genotype data is a part of what they do, and it's not something that's just available to the largest organizations in the space. The other thing that I think that's from our perspective is a major distinction between those industries and what can and is starting to happen in the two cattle markets is that there is much more of a limitation on the ability to generate genetic data at the major scale production point in the swine and poultry industry relative to the beef and dairy industry, because the way their pyramids work, the actual production volume is happening far downstream in an animal who has a value that is just too low to really justify a genotype per se. Whereas, we do see a lot of opportunity in, and it's something that will take time to fully develop, and there'll be a lot of different pieces that need to come together for that. But in the beef industry, kind of the vision is that, we've got 30, 40 million beef head born every year, and million in the US, and we want to figure out what we can do if we have genetic information on all of them, and how can that address some of the key challenges of value creation up and down that beef supply chain, and how can that help unify that supply chain. That kind of a question is probably not going to come to play in a production hog barn, though there are absolutely opportunities and needs for that kind of data to help address questions of disease and health and consumer quality and things that all stem from that. So there are some opportunities where the fragmentation of the dairy and the beef industry will allow certain technologies to have impacts in ways that might be more difficult in the other industries.
Right. Turning what sometimes is considered a disadvantage into a potential strong advantage.
Sure.
Yeah. Okay, this is so great, Jesse. Very last question. It has been quite a year in 2020 across meat and livestock, across the broader industry. What's an observation you had about the industry this year?
Yeah, great question. And you gave me the heads up at the beginning of the conversation. So I think that we, going back to that theme, Ben, I was really excited and something that you covered quite a bit in seeing all of the activity around direct-to-consumer beef. And I think here in December, it's a little interesting to see how it's continued to play out. But I think it has highlighted the opportunity around really fine-grained understanding and customization of beef animal performance around capturing as much value for the end user as possible. And our perspective is that there are a lot of opportunities for genetics to play a role there, and we're excited to see how that trend continues.
Awesome. Jesse, thanks so much for joining us today.
My pleasure.